This is Dr. Mahmoud Al-Odeh for Quality Assurance. Uh, this video is about the P chart. The P chart is a concept or a tool that we use it in quality to measure the behavior of a process. Similar to the X and R chart, but the difference between the X and R chart that the P chart is used for data when we have a pass-fail data, 0-1 data, not a measurement, not like the length or the weight. Here, for example, in the P chart, we have two possibilities, and we say whether pass or fail. We look into this example for like just to clarify this idea. This is an example for a production manager at a light bulb. At the light bulb plant has inspected the number of defective light bulbs in 10 random samples with 30 observations each. Following are the numbers of detective light bulbs found. So when we talk about light bulbs, whether it's working or it's not working, same thing for number of eggs in a carton, number of eggs broken and unbroken. So this kind of data, whenever you have this kind of data, pass or fail, two possibilities, then you have to use the P chart. So let's go ahead and start on developing the P chart for this kind of data. What you need to do first, first of all, you have the data given to you. Identify the sample size. We have a sample size of 30, number of samples to be 10, as this is given in the question. As you see here on the second line here, you will see this manager inspected the light bulbs in 10 random samples, so that's the number of sample. Each sample we have 30 observations, so number of samples is 30 observations. And this is important because you need to know exactly the total of the samples that you inspected. So in number of defective here, sample number one, we have one defective, one broken light bulb. And therefore, what you need to do is you have to divide that. You need to find the percentage of the defects for this particular sample. And we know each sample consists of 30. So 1 divided by 30, that would give you a 0.033. Again, what the p-value? It's the percentage of defective parts in each sample. You find out what would be the defectives, the number of defectives in that sample divided by the total inspected. The total inspected in that specific sample. Sample number two, we have 3 defective light bulbs, so that would be considered as a 10% of the 30 light bulbs. So 3 divided by 30, that would be 0.1 or 10%. Same thing for 10%. We do the calculation. If you would like to use as a percentage here, you could change that to a number of percentage, just to give you to make sense for you. Now, some people they think they're not sure what's the p-value, but the p-value again, it's the percentage of defective parts in each sample. Whether you use the percentage or you choose just a number, either one would be fine, would be okay. Now, let's move on to the second part of this, which is right here, the P bar, which is the center line. Basically, this is what we call the center line. And again, I took in the previous video that whenever we have an X and R chart, what we do, we start with calculating the center line. So this is a really important parameter for the P chart. In order to calculate the center line, or the P bar, would be the number of defectives divided by the total. Now we find out what would be the total defectives in all the samples. So you add 1 plus 3 plus 3 plus 1 plus 0 plus 5 plus 1 plus 1 plus 1 and plus 1. Divide that by the total inspected by 300, which is 30 times 10. That would be 300. So as you see here in my cell right here, C19, what I did here, I added all the defective parts using the sum function, and divide that by 300, which is the total inspected, all the bulbs that we've inspected. Now, the second part is to find the sigma, the standard deviation for this population, for this sample. What we do, the sigma would be the square root for p bar times 1 minus p bar divided by n. So the square root for C19, so I did find the p bar right here, times 1 minus C19 again, divided by 30. And this is here, we use it for only one, for the only one sample. What would be the standard deviation for each one of these samples? So this you will get 0.042. And next, what we need to find the upper control limit and the lower control limit. Starting with the lower control limit, would be the based on here the p bar minus the 3 sigma. P bar would be 0.056 minus 3 times the standard deviation, 0.0422, and that would give you a negative number. So once you see a negative, there's no negative number in the p chart. Take a note, this is really important. No negative value in the control chart at all, whether X, R, P, or C. Whenever you see a value of negative, just change it right away to a 0 value. And then we calculate the UCL, the upper control limit. That would be the P bar times plus 3 times the standard deviation, and that would give you 0.18. Now let's go down here, fill this information. So we know that this is going to be a 0 for, I'm going to delete all this one just to show you what I have. So 0 for the lower control limit. The center line would be equivalent to this one, 0.056, and I want to copy this value for all the cells. So I'm gonna lock that value here by adding a $sign before and after, and then you double click on the right lower corner. For the upper control limit, same thing, we need to take this value, which is 0.18. We need to lock this value by adding a $sign, and this would be a function of 4, the easy way. Double click on the lower corner, and that would copy the values to the rest of the chart. Now, if you look into the chart, we have started with the center line in the middle. This is dotted line, upper control limit, lower control limit down there. Now let's move on to the P. Now the value for P, this is what we have from the percentage of defective parts, which is equivalent to these values right here. So we start with the first one, then double click all the way down to find what would be the P value. And as you see, the chart has been created with a center line, upper control limit, and lower control limit. So with that, that's how you create the P chart. I hope this is helpful. Please let me know if you have any other questions. Thank you.